All right, hi everyone. I thought I'd just run through some of the new features in the version 29 firmware and software. There was an update on Crowd Supply sent out to the mailing list if you're signed up for that went through a bunch of these, but thought I'd kind of show them off. And there's actually been even a few new things since that email was written. So yeah, let's take a look. So here we are, we're running version 29.17 here, and I did update the firmware on these two boards that I'm running right now to version 29 firmware. Yeah, if you're not up to the version 29 firmware when you start the software, then it will not show anything. It won't show any traces or take any data, and it'll give a little message in the printout window just saying, you need to update to version 28 or above firmware in order to use this software. Yeah, so once you do file and then update firmware, then you'll just need to power cycle the board after the firmware is completely updated. Don't power cycle the board while the firmware is updating, otherwise you'll need to manually upload new firmware. And then once you power cycle the board, restart the software, and you'll be up and running with version 29 software firmware and running the new software. Yeah, so yeah, you will need to check out the version 29 branch on GitHub, or download the version v29 zip file on GitHub. Just make sure you're selecting that branch and you'll get the newest software and firmware, or at least the version 29 software and firmware. I'm sure there'll be more things in the future. Okay, so yeah, one of the first big new features here is just the triggering, especially at high frequencies. So I am running here a 350 megahertz square wave from my signal generator. It's this thing here. And yeah, if we zoom in a bit here, you can see it's nicely stable, and it's always triggering at the exact right instant. And this wasn't the case before. I hadn't tested it at these higher frequencies where you get multiple triggers so close together, basically, was the issue. And it would have trouble picking where to say the trigger was when you have so many close together. If you look at the samples here, so I just turned off the upsampling so we can see the actual individual samples. We're going at 3.2 gigasamples per second. So this is like 2 nanoseconds here, and if we pause so we can see it, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, maybe 10 samples or something like that. And yeah, the ADC actually kind of spits out 40 samples at a time, and that's how the FPGA reads them in. So yeah, when you start to get multiple trigger edges within that those 40 samples, there started to be troubles. So that's all fixed now. The FPGA goes through those 40 samples and it figures out which one has a nice trigger edge, and it'll report back the index of the sample which is first crossed from below to above the threshold trigger line. So that helped a lot. If you just do that though, then there's still a little bit of jitter. So let me turn off the new feature so we can see how much jitter there would have been. So even with that firmware fix, there still would be a little bit of jitter in the trigger. And the reason for that is, if you again pause and we look at the samples, this particular trigger, okay, this was the first sample which went from below to above the trigger threshold. But this one did it there, so this amount of time after the trigger trigger time, or the desired trigger time. The next one though, okay, let's just do single. The next one could be, let's get a good example, all the way down here, so just a little bit closer, or it could be up there, or it could be, what if it's way up here, right? If it's up here, it's actually a little bit later, and so the waveform is going to shift around depending on the phase of when you're sampling compared to the phase of the wave. So you're always going to, no matter what, have within one sample of jitter in the trigger time. And just in firmware, there's really not too much you can do about that. So what do you do? Well, what we do now is so let's say you get an event like this. What it calculates is it knows from the firmware where these two points are, which points went from below to above the trigger threshold, and all it does is going to do a linear interpolation of those points, and it's going to say where does this line meet the trigger threshold line, and then what is that distance, right? So it's going to find this distance, either could be positive or negative, and then it's going to shift the whole waveform by that amount, so that then the waveform always lines up so that that line crosses at the desired trigger threshold and time. All right, so if we turn that on, I'll still do single capture so we can see. So we turn on this trigger stabilizer, and that's on by default, and it will apply that correction. So now every time you do it, it's going to go exactly through that desired point. Okay, so that really worked out well, and if we turn it on, you can see it's just totally stable going through that point there. And also the upsampling is on by default now for these zoomed in time factors. So it'll be set to an upsampling of 4, and that just makes it look a lot cleaner. The upsampling, in case you're not aware, is adding these extra samples according to a Fourier transform thing, so that it would be perfect for a sine wave of the main frequency. It's adding these extra samples along the way, just so you get a smoother line, right? Without it, you get a lot less samples, and so you get these jaggedy looking lines, but you can add a lot more samples along the way. It gets slow if you try and add too many, so I find 4 is about the right amount, and so you get basically 3 extra samples, just kind of filling in the gaps and making a nice smooth curve. So yeah, that really works well. And even if you go up to we can go up to, I don't know, 1170 megahertz, then we're still going to get a nice smooth sine wave. um, you'll see a little bit of like, jitter back and forth. That's, still kind of unavoidable because it's just coming from the upsampling. Like if you look at the individual samples, they're still being fit so that the algorithm is working and that line between the two samples is crossing at the exact right time. The issue is when you turn on the additional samples for the upsampling, then there's a little bit of, it's not a straight line anymore. It's following a sine curve, and so the calculation is not going to be perfect. It's an approximation. So yeah, there's a little bit of jitter still when you do the upsampling, but now you're talking about what is that? Maybe 0.1 nanoseconds or something like that, which is pretty acceptable, I think. Okay, so that's the new trigger. Let's talk about some other things. So yeah, we can also change the line width, right? So we can go to 3 pixel wide, or 2 or 1, or as big as you want. That's helpful in some cases. It does slow down the drawing a bit. So especially like if we have the upsampling off, you can see we're getting like 64 hertz on my computer here, and with a wider line it slows it down a little bit to okay, now you're only getting 34. It's got to draw a lot more pixels and figure out where they are. But yeah, that can be handy. Sometimes you want a wider line. We talked about the upsampling being on by default, and yeah, it does turn off once the time factor is greater than 1, basically. It'll still say that the upsampling is at 4, but it is actually off. Okay, let's see. So yeah, let's put back a slightly slower signal again now, and I want to show you the new rise time fitting. So we can just go to 35 megahertz, really slow. And yeah, so now we have a nice edge here, and you want to know the rise time of this edge. This worked before, but now you can, when you measure the rise time, there's this rise time fit lines, which you can either turn on or off. It's on by default when you're measuring the rise time, and it'll show you the lines that it's using to actually do this fit, so you can kind of understand what's going on and have a little more confidence in the process. There's also this fit fraction thing here, which was there before, but you'll see that it actually now you can see the lines, and as you increase the fit fraction, it's actually, which is the fraction of the collected data that it's around the trigger time that it's using to do the fit. So as you make that wider, then it's actually, you can see the extra data points that it's using to do the fit, which is going to make it more stable. But if you have it too big, then you're going to get a bad fit because you're not fitting the correct shape here. So here you would want to go back down to using like a smaller window, and then you can see exactly what you're fitting. And yeah, that's working well. So we're getting a rise time of like, I don't know, 0.3 nanoseconds, which is pretty good. We're just in single channel mode here, not like doing any oversampling or anything. So we have a bandwidth of a little more than a gigahertz, and because we only have 3.2 gigasamples per second, only 3.2. gigasamples per second. So this is consistent with like 1 or 1.5 gigahertz of bandwidth. And yeah, so that's nice for kind of just seeing the rise time, and that'll work well if you do a falling edge trigger. Then it will show the falling, and it'll give you a negative rise time. Of course, if you don't fit enough data, then it won't work, so you'd have to expand that out. So now we're getting negative rise times because we're doing falling edge. Probably fit too much. Okay, let's see what else. Yeah, so we can also now do persistence of traces. So like the old-fashioned kind of oscilloscope CRT view where the traces take a while to fade out. So you can turn on this persistence, and now you can see that the traces kind of stick around for a while, and when you stop, the old ones kind of slowly fade out, right? It's kind of cool. So up to 16 traces can be shown at a time by default. It's just a parameter, but it'll get kind of slow if you're drawing too many traces at the same time, and this just changes how long they stick around for. So kind of the magnitude of the effect here, but I think it looks pretty cool, and definitely kind of helps you see the overall shape a little bit better. It does slow down the drawing significantly, so use it sparingly, but yeah, it's definitely nice to have around. Okay, so that's persistence. Then there's some littler things you can do, like file, take screenshot, and then that'll save a screenshot of this whole window to a PNG file in the same directory as you ran the software from. It'll give it a little date and time string on the end of the file name, so they'll be uniquely identified as long as you only take less than 1 per second. Yeah, that'll work in the FFT window also. You can do file, take screenshot, and it'll take a screenshot of the FFT window, and it'll have a little FFT in the file name. While we're looking at the FFT, you can actually also do view log scale now, and that's useful for some things. We can see all the odd harmonics of our square wave there, and yeah, that's useful. And let's see, so you can also do this panning and zooming. So before, when you kind of like dragged around with your mouse on the window here, it would be able to pan and zoom and do all sorts of things. If you want to do that now, you have to turn on pan and zoom in the view menu, and then you can move around the window, and you can with the right mouse button you can zoom around, and I think even the wheel does stuff to like zoom in both directions at once. The right mouse button will zoom like horizontally if you move it horizontally, and vertically if you move it vertically, and you can pan around. So that's really useful for like zooming in on features, but then you don't want that happening all the time. By the way, you can go slower and faster just to like reset the window to the usual place, and you can turn off the pan and zoom, and then you won't be able to drag it around. You also need the pan and zoom on in order to right click. Oh, actually, I guess I got rid of that. Yeah, you used to be able to right click on the window and be able to like change settings of the plot and stuff like that, but yeah, we don't really want users to be able to do that, so that's disabled now, just so people don't get confused. Yeah, and I think, does that work for the, yeah, in the FFT window also, there's no panning and zooming allowed in the FFT window. Okay. So let's see. Another thing is you can now drag these trigger lines around. So you can drag the trigger time, and that would be just the same way that doing the trigger time over here worked. So you can just drag the lines. And same thing for the trigger threshold. You can drag that up, and it does the same thing as the slider on the right would do. Remember that you can only change the trigger time when the time factor is greater than 1. So you can do it here, but you can't do it when you're too zoomed in. That's kind of just the way the software works. I could kind of work on that, but it's a little tricky because this is actually just a zoomed in view of the whole data. You're not actually taking more data when you're or less data when you zoom in like this. You're just changing the view. So yeah, it's a little different, and you can't really drag the line anymore. And you can also do the keyboard keys. So if you're on the main window and you press like left and right keyboard keys, you'll go slower and faster. Right, faster would be to the left, and slower would be to the right. Maybe I should reverse that. That's a little weird, actually. I'm not sure. But anyways, yeah, you can go faster or slower with the keys, and you can change the offset of the signal that's currently selected, the channel that's currently selected, by going up and down with the arrow keys. And if you hold shift, then shift arrow up or shift arrow down will change the gain of the signal. So that's a little bit handy. And this is really nice. On the right axis now, you see that there's a new scale shown. So this says voltage for board 0 of channel 0, and it's in volts. So for your selected channel, it'll do the calculation now for you, where you're converting from voltage in divisions. So this is 2 divisions, and we're on 200 millivolts per division, so that's 400 millivolts. And so instead of having to like do that in your head all the time and trying to figure out, oh, what voltage is this, it'll just show you on the right for your given signal what your voltage scale is. And that'll change, of course, depending on the gain. So if you increase the gain, now we're at 100 millivolts per division, so 5 divisions is up here at 500 millivolts. So if different channels have different gain, then you need to select the different ones. So if I go to board 1, I have a different signal on there. That's going to have a gain of 200 millivolts per division still. The red one, by the way, you can click on the signals in order to select that particular signal. Just left click with the mouse. So you'll see that the voltage scale also changed. So here, this is like 400 millivolts, and when I click on this one, it's only 200 millivolts, and it says voltage of board 1 channel 0, and that's because it's showing the voltage scale for that channel. All right, so yeah, that's most of the features that I wanted to show off there. You will also notice that the main voltage scale has changed slightly. So now, instead of 160 millivolts per division for gain 0, we're at 200 millivolts per division for gain 0. That was just an ADC setting that can be changed. You then get a little better kind of more human scales for your voltages. So you kind of go from 400 millivolts per division to 200 to 100 to 50 to 25 to 12.5, which is not so human, but whatever, and then you get 10. So, whereas before it was like 320 and 160 and 80 and just a little bit more weird voltages. So, and you also get a little bigger range for the voltages that the scope is able to handle and show. So, now you can get a full 4 volts peak to peak here, whereas before it was 3.2. So I think that's a little bit better. Of course, you lose a little bit on the for really small signals, but you can always increase the gain, and there's a bit of noise there anyways. So I think it's better to have the scale this way, but it's just a software setting. We can change it back. And yeah, so I think that's most of the main features. I guess the only other thing is that this version of the software now nicely supports the new version 0.1 of Haasoscope client, and so yeah, you have to start up this software, and then you can connect to it from Haasoscope client and get all of this data flowing into Haasoscope client, and that all works nicely. There were a couple little fixes that had to be done to really make that work, but it's working really well now, and I'll probably have a separate video on how to example of how to use that. Okay, so hope you enjoyed that. Let me know what you think about the new software, any issues or feature requests, whatever, and enjoy.